Right. And today we're going to have a look at hyperbola. And I don't know what's to say about hyperbola. It's a funny shape, but let's just get straight into it. So, hyperbola is defined by the function y equals 1 over x. And so that's the basic function. And so, what does that look like? Let's just have a quick sort of sketch of it. So, um, what happens is that as x gets bigger and bigger and bigger, 1 over x gets smaller and smaller and smaller. And so what that means is that the graph gets, just getting from my blue pen, as it comes out here, the x gets closer and closer to 0. So it's getting smaller and smaller and smaller. As x gets smaller and smaller and smaller, in other words, as we go that way, y gets bigger and bigger and bigger. And so what that means the graph looks like is it sort of like curves up and it gets closer and closer. And so it looks like that. Okay, that's what the positive side looks like. How about for negative values of x? So as x gets bigger and bigger and bigger in a negative direction, so going out that way, then it becomes a tiny, tiny, tiny negative fraction. So it comes out like that. Okay. But as x gets smaller and smaller in a negative direction, so going that way, then y gets bigger and bigger in a negative direction. So it looks like, oh, it's a bit lumpy. And so it comes down, it looks like that. And so that's what the graph of y equals 1 over x looks like. And because it gets closer and closer to the axis but never touches, what we have is we have asymptotes there and there, so along the axes. So when y is equal to 0, we get an asymptote, and when x equals 0, we get an asymptote as well. So that's what the graph of y equals 1 over x looks like. So what's its domain? Well, its domain, it's valid for all x values work for this, except when x is equal to 0. And so it's all real values, but not 0. Okay, so that 0 is the only one that doesn't work. And for the range, what are the valid y values? Well, y is valid for all values except for 0 again. So the range is all real values, but not 0. Hopefully that makes sense. So that's the basic function. What does it look like when we have some transformations and translations and reflections and things added to it? Let's have a think. I haven't left myself much spare space here, have I? So I might just delete that graph. Well, I'm pretty happy with that. So I no, I got to delete it. It's just not going to work. Okay, you can rewind the video if you want to have a look at that. So that was the basic function. So what does this transformed variety look like? Let's have a look. So remember that x minus h and the x plus k, what that does is it moves it to the left and to the right, okay? And so what that will happen is that, oops, again, I've dropped my pen. So what will happen is that that x minus h on the bottom line, that moves the asymptote h to the right. So we're going to get an asymptote at x equals h. And that plus k, that moves the that asymptote there to y equals k. So we're going to get asymptotes there and there. Okay. And so what you're going to get is you're going to get the top part of your graph looking like that, and the bottom part of your graph looking like that at those two new asymptotes. Now, if this is what happens if a is greater than 0, okay, you're going to get those. And then I'll do another one for what happens if a is less than 0, if a is negative. And so again, for the same h and k, really run out of space today. Not great. And that's a terrible asymptote. I'll stick with that. So if you got your asymptotes of y, sorry, not y, x equals h, and y equals k, we got those. What then if a is negative? So if a is negative, then what happens is that the asymptotes actually swap, not asymptotes, the graph actually swaps the curve. So it comes up here instead, and it's on this side over here instead. So it becomes on that side instead. So it flips around because that a less than 0 is actually does a reflection in the y-axis and the x-axis. Okay, so so that's what the graph looks like for there. And so what will the domain be? So the domain of that function there, if we've got the transformations included, is that you got the all real values except for the asymptote, so except for whatever the h value is. And for the range, again, all real values, but for whatever k is. k will also be not within the range. So I hope that makes sense. Let's go do a question to sort of make sure that gets more solid. Okay, all good. Let's try it out. So first question, sketch y equals 3 minus 2 over x plus 1, stating maximal domain and range. So maximal just means what's the maximum amount of domain and range we can use? What's the most biggest possible domain that we can have? Okay, so let's have a think about this. What I'm going to first do is just rearrange it. I don't like it written like this. I'd like it written the way I want it written. So I'm just going to write this as negative 2 over x plus 1 plus 3. So I'm sort of going to rearrange the order there so I can clearly see what's h, what's k, and what a is here. Okay, so let's just have a think about it. What that plus 1 is going to do, it's going to move it towards the left, because remember it's x minus h, so we're going to get an asymptote at negative 1. Okay, so asymptote at negative 1 when h is negative 1, and k is going to be plus 3, so we're going to get an asymptote at plus 3. Also, that negative there is going to mean that it was like the second variety, so it's going to be on that side. Okay, so that's going to how it's going to be affected. So let's have a bit of a sketch of this. I'm going to make this one a bit bigger so I can actually sort of see what's going on. All good. So firstly, we're going to have an asymptote at x equals negative 1. All right, so x equals negative 1. That's my vertical asymptote. Then we're going to get a horizontal asymptote at positive 3. So I'm going to have y equals 3 is my positive horizontal asymptote. And it's going to be the other sides. And so what we're going to have is you're going to have on there, make sure you don't never hit the asymptotes. On a computer screen, sorry, it's going to come up. You know what, I'm going to get rid of that x equals negative 1. It's really bugging me because it's in the way. I'll put it on afterwards. All right. So got this line coming up. That's going to go up there. And we're going to have one coming up here. And like that. Okay. I'll put in my x equals negative 1 down here now. And y equals 3 on there. So it's going to look like that. So that's what the negative does. We could also put some, depending on what the question asks for, it'll be helpful to know what the x and y intercepts. It looks like we're going to have some x and y intercepts there, so that would be helpful to find out. So let's just quickly do that, because that always gives us more information. So y-intercept when x is equal to 0. So y is equal to negative 2 over 0 plus 1 plus 3. So that's equal to negative 2 plus 3, so y is equal to 1. That turned out nice. And similarly, the x-intercept when y is equal to 0. Therefore, 0 is equal to negative 2 over x plus 1 plus 3. Therefore, negative 3 is equal to negative 2 over x plus 1. I'll flip both. Oh, I'm going to run out of space here. Silly. Therefore, I'll times both. No, I'll just flip. Should I just flip? Yeah, I'll times both sides. So negative 3x minus 3 equals negative 2. I just times both sides by x plus 1. And negative 3x, add 3 to both sides is 1. Therefore, x is equal to negative 1/3. Okay, so that just helps me out a bit there. I know that my y-intercept is 1. And my x-intercept there is negative 1/3. And that's my sketch for y equals 3 minus 2 over x plus 1. Hope that makes sense. So always use a ruler, obviously, when you're doing it. For asymptotes, don't let the lines touch, don't let your curve touch the asymptote ever, and don't have your sort of line coming away from the asymptote ever either. Make sure they're always getting closer and closer, and just stop just before you get there. Don't need to get super close. Okay, makes sense. So that's how we sketch a hyperbola. How do we determine a hyperbola? Let's have a look. Let's have a look at this question. We want to know the equation of gx here. So let's have a think about it. We've got gx, and we know it's a hyperbola just by looking at the shape of it. It looks like on the bottom line, What's my vertical asymptote is x equals 1. So on the bottom line here, it's going to be x minus 1 on the bottom line. And over here, it's going to be minus 2 because my horizontal asymptote is at -2, so it must be there. And we're going to have some a on the top line. Okay, and we don't know that value of a. What we do know is that our y-intercept is -4. And so we can sub in 0, -4. And so therefore, what we get at -4 is equal to a over 0 minus 1 minus 2. Add 2 to both sides. A over -1. Therefore, a is equal to 2. And we are done. Therefore, gx is equal to 2 over x minus 1 minus 2. That's my answer. Hope that makes sense. That is hyperbola.